Hello, and welcome back to this other episode of Mambel Technology Group. Today, in this new episode, what we're going to do, we will create a high availability solution. High availability simply means that you want your applications to be always up and running. And in this series, we will be creating an always on availability group. So take a look at our diagram here today. In the last series, we saw how to create a Windows Server failover cluster, and which is the primary step to creating an always-on availability group. So what we did was to create a cluster between node 1 and node 2, and I showed you how to create the cluster, how to do the cluster validation, and what are some of the components that were required to create a cluster, like an IP address, the cluster name, and also to run the validation test. And at the end, I showed you how to move the core cluster resources from one VM to another virtual machine, or from one node to another. So right now, what we're going to do is to create an always-on availability group. And basically, what is always-on availability group? This is a technology that was introduced in SQL Server 2012 to replace the database mirroring, which is kind of a little bit obsolete and out of support from Microsoft. So always on is basically having a group of databases that will fail over together as one group in case of a disaster, or in case of something that may trigger it to fail over. Unlike database mirroring, you could just have one database that will fail over to the mirrored server. But in always on availability group, we have the primary node, we have the secondary node. And the primary, most of the time, will always accept read and write connections. But the secondary, on the other hand, can either accept read connection if that is configured, or it can just be a standby. So I assume that everybody here has a knowledge about always on availability group. I'm not going to go too much into details, but I just want to walk you through how to create that. And for this, we have our SQL Server Management Studio already installed, and we will be using Adventures Web 2019 to create our availability group. So let's go ahead and do that. Before we move forward, let me just bring up my page here. So what is always on? Let's assume we have two servers. We have our production server here. So I'm just going to call this one prod. Or let me just call this one node 1. And we have another server here. And I will call this one node 2. And in this primary server, we have, let's say, a couple of databases in here, and maybe there are some production databases. And these databases are a group of databases like this. So, and then we also have some stand or individual databases that are still in this server. So the first step in setting up an always-on availability group will be, first of all, to create a Windows Server failover cluster. That is what we did in our last video. We created a Windows Server failover cluster to host our availability group. So this is our Windows Server failover cluster, and these two VMs are running in a domain, and our domain here is mtg.com. This is our domain. Now, this server is an independent server. This is another standalone server. And basically, in this setup, each server has its own separate and individual disks here. So let's assume this is a disk for your data files. You have one for your log files, you have one for your backup, and you have one more for your 10 GB. Same thing here. Each server has individual disk, right? So this is what makes the difference between always on and failover cluster instance. In the situation of a failover cluster instance, we will be using a shared disk, and the shared disk is either going to be used by one or the other instance. Two instances cannot have access on the shared disk at the same time, and that is the point of failure. If a disaster was to occur, or if something was to happen and the disks go down, the entire failover cluster instance will go down. Now, because these manage their own individual and separate disk, it is a little bit more better than the failover cluster instance, even though it has its own downside. Now, to create always on here, you will have a couple of different ways that you can set that up. But the first thing is to have this cluster, and our cluster, we called it, when it was created, we called this one DB cluster. That is the name we gave to our cluster. And because they are within this domain, these two nodes can talk to each other. Now, this group of databases, if something was to happen, let's say to this entire instance, then what is going to happen is that these databases, they will fail over together to this, they will fail over together to this secondary node here. And at the end of the day, you will have all these databases sitting here, right? So when there is a failover, all these databases will migrate from this node to this node. And in an always on availability group setup, the server that accepts read-write permission or read-write connection is called the primary. It's called the primary replica, and this one is called the secondary replica. Is called a secondary replica. So if the primary goes down for one reason or another, all these databases will fail over to the secondary node, and your server or your activities or your business will still be up and running, right? So the other databases that are independent and that are not part of this availability group will not fail over, and consequently will be inaccessible in case something happens. And how is connection done to this availability group? How do you know which server, if you have a front end application and you're just connecting at the front end, how will you know to what server your application is going through? So with always on availability group that was introduced in SQL Server 2012, there is this feature that is called the listener, right? That is a feature. It is called a listener. So basically what happens, let's assume that you have a user here, and this user is called Eric. And Eric is trying to connect to his online account, and that account or that application hosts the databases at the back end. What happens is always on has what is called heartbeat, so they equally send a couple of pings to each other, talking to each other now and then, knowing that they are always up and running. And this, you can set up this through their health detection, always on health detection. So what is done is that since it is the primary server that can accept read and write connections or write connections, once Eric sends a connection maybe to his account, the listener already knows which one is the primary and which is the secondary, and it will redirect the connection to whichever is the primary at that given point in time, and your connection will be established and you will have access to the back-end databases. Now, in a situation where this phase or the node 1 goes down, then this will not accept connection anymore, and so the next connection that will be initiated by Eric will be rerouted to the new primary, and this one here will become the new primary, and you will still have access to your databases. And the good thing is, Eric here wouldn't feel or wouldn't know that there has been a change or a failover that has occurred at the back end in the databases, right? His connections will still be up and running and he wouldn't feel anything. Now, in an event that this one becomes the new primary and this one is down, when this one is fixed and it comes back up, it becomes the new secondary. Now, depending on what failover mode you have put in place, this one can now become a new secondary and you can decide to fail over back so that it takes the place of the primary, or you can just allow it to be in a secondary mode. Now, the second thing is sometimes some people, depending on the use case, may decide that the secondary server becomes readable. And in that situation, when you are performing a connection and you want to only read data from the database, the read intent has to be specified in the connection string. And this is a topic for another day. I'm not going to elaborate more on this. So you have to specify the intention of your connection to be read only, and only in that case will your read access or your read connection be routed to the secondary replica. And in every given point in time, either of these nodes can become the primary or the secondary depending on the activities that happens at the back end. In more videos that I'm going to load online, we will see more into the internals of always on and what are the different modes of synchronization in always on, how a failover occur, what causes it to occur. So keep following our channel and subscribe, like our videos, and comment. So let's move right away to the practicals. Right now, I'm going to start with our primary node. So I have here my SQL Server Configuration Manager, and I have the latest version. Before you do this, you will have had installed your SQL Server. And what we're going to be using here will be SQL Server 2019 Enterprise Edition. So stay tuned. So I will go ahead. I have my SQL Server already, and that's my product key. So I will go ahead and do a quick install of my SQL Server 2019. I assume everybody knows how to install SQL Server. So this is just going to be a quick one to install my SQL on both instances. And as you can see, I'm installing SQL Server 2019 Enterprise Edition. And I'm just going to select some basic features that I need right now. I don't really need much. Okay, these are some of the services I need. I need integration service because I might probably use that. So before you install SQL Server, you definitely need to know what are the services that you will need. What are the features? You don't just go ahead and select any feature. This is usually you select feature based on their uses. And I'm just going to do a name instance, and I'll call this one Node 1. Since I'm installing this on Node 1. So this is a fast track video for anybody who wants to know how to install SQL Server and you've never done so. So basically, I will change this one to MTG and I'll use the account I created in the Active Directory as my service account to run my SQL Server database engine. And my startup mode, SQL Server has two types of startup mode, either automatic or manual. And you can also disable the startup. So we should be good at this point. And I'll click on next. It's validating my credentials and everything, validating the service account. So I need to add a current user because that's the user that is going to be running the SQL Server services. And my authentication mode will be mixed mode. I like mixed mode because I'll be able to create some SQL users, and I can decide also to use some Windows users. And my data directory, I'm not going to send everything to the C drive because I don't want to saturate my operating system. I created best practice. Microsoft recommends to have different drives for your files. So this is my data drive. I'm going to create a new folder here called data. And in this folder, that is where all my data files are going to go. And for my log files, we already know that when you create, when you install SQL Server or you create a database, it comes with two files, right? Two default files, the log file and the data file, .mdf and .ldf. So to avoid IO contention or latency, it's always good to separate everything to create different drives so that your SQL Server can run quickly and smoothly at the level of your disk, right? If everything is in your disk will be saturated and it usually creates um, a high I, and you want to avoid that. So this is my backup file. Everything is done for my TempDB. I'll also change the directory for my TempDB. I'll remove the C drive and add the TempDB folder. I have my TempDB here, and I'll call a folder here called TempDB. Okay. So basically, I'm done the maxed up. I'm not going to set anything for maxed up right now. Every other thing. So this is just a quick install. I'm not really specific on what I need here. And even the MDB files and everything, I'm not specifying anything. I just need to do a quick SQL Server install to create our availability group. Specify the controller machine name. Did I choose a feature that I don't need? I think so. I will have to remove it. And at this point, all our services, everything has been checked. This is just a resume, a summary of everything that we've done so far. Right. I'm just going to click on install and my SQL Server should be ready in a couple of minutes. All right, let's proceed. Now our SQL Server is fully installed and but we don't have our database yet. So the first thing in the steps of creating an availability group is first and foremost going to the configuration manager and enabling the always on availability feature or the always on feature. So this is my configuration manager, as you can see, and this is my node one. If I right click here and go on properties, we have always on availability group here. Right now you can see it picked the name of our cluster already, the DB cluster, but we have to enable this feature. If not, we will be unable to create always on. For example, if I try to expand this folder, the always on high availability group folder, see, it doesn't work. So we need to enable this, and any changes that are done in the system, especially in the configuration manager, then you will need to restart SQL Server services for that to take effect. If not, it's not going to work. And we have to make sure that we do the same thing on both nodes. Right now, the always on feature is not enabled. So let's go to the configuration manager and do the change, perform the change. Right here in our configuration manager, and my system is pretty fast, as you can see. So we have node 2 here, change the properties, enable always on availability group, and restart the services. And you want to make sure sometimes the services restart, but the SQL Server agent doesn't restart. So that is something to pay attention to. Once you restart your SQL Server services, your SQL agent might as well restart. And sometimes you'll have to manually come in and bring it up. So it's up and running. At this point, I have my node 1 here and my instance name is node 1. You can see from the name. And I'm going to use this as my primary. At this point, let me disconnect this and make a new connection. Node 1. And let's see this. Oh, I think I will have to restart. I thought I restarted the services already. Let me see. Restart. Okay. While it's restarting, let me try to connect node 2 from this VM. And they are in the same domain and everything is enabled for them to be able to communicate. So let me connect on node 2 and verify. Okay, now we enable the always on availability group feature and you can see now we can expand the folder. The same should be for node 1. Let me refresh this and you can expand it right now. So for now, we don't have no databases. I'll go ahead and restore the AdventureWork 2019 database on this node 1, and that is what we'll be using for our always on availability group. So I'll right click and restore database. I already have a copy in my backup folder. I just have to pick that copy and restore that. I thought I had a copy in my backup. Let me check first and make sure I have a copy in my backup folder. If not, we will have to copy over for sure. I have it here in my backup folder. And just paste this and look for all files. Yes, I should have my AdventureWork 2019 here. Okay, I'll relocate the folders and everything else is good. Good, bingo. So the first step in creating an always on availability group is to perform a full backup. And by default, AdventureWork will always come in simple recovery mode. So with a database also has to be in full recovery mode for you to be able to create an always on availability group. It doesn't work in simple recovery mode since transaction lock is concerned. So let's verify this and make sure and change it to full recovery mode because by default it comes in simple recovery mode, as you can see right here. Change it to full recovery mode. Okay, the next step is to take a backup. The backup is important and it's necessary to initialize the always on availability group. And for me, I will drop the backup in my shared folder in the domain controller, the shared folder we created earlier. So I'm just going to go here and copy the path. This is what I want to use for my backup. I remember I created this for the quorum, but I'm just using this in this tutorial so I can perform I have a central location for my backups. So I will do a quick backup here and I'll add this file path here and I'll call this adventures, AdventureWorks. I'll call this 19.bak, the extension for full backup. So basically what this is going to do, it will initialize my AdventureWork and I can add it to my availability group. So to create an availability group, you just expand this, right click, and using the wizard, you can do this using the wizard, the graphical user interface, or you can use the script. But I'm just going to go ahead with the wizard. So this is my interface and it's basically telling you everything about always on. Here, I need to give a name. So I'll call this demo AG. That is a name. And the cluster type, and remember for always on availability group, you can have the cluster type as a Windows Server failover cluster, an external, or a clusterless none, right? And in this case, since these two servers are in a cluster, you can see that they my Windows Server failover cluster is detected. And this is database health level detection to know if a database in the availability group is healthy or not. So, but with SQL Server 2022, and I will show you how to create always on with SQL Server 2022, you will notice that they have a new feature. This contained availability group is enabled in SQL Server 2022, and that is something really beautiful, which basically comes to resolve the problem that we have with our current versions of SQL Server, where when there is a failover or where it doesn't synchronize object level, server level object, like your SQL logins and your jobs are not synchronized if a failover occurs. You need to manually script out your jobs and create it on all the databases participating in the availability group. But with SQL Server 2022, you can enable containment, and what that does, it creates two system databases, that is the master database and the MSDB. It created under the availability group that you will create. And basically what this does, it is coming to leverage the problem where we had to synchronize server level objects in always on availability group. And by default, anything that you create within the contain availability group system databases will be fully synchronized. I think I will create a different video and show you how that is done. So here, let's go to next. And you see, because we took a full backup, it says this meet the prerequisite. So this is a database I want to choose from my availability group, and we'll proceed. Now here you have to specify and add the secondary node. And with SQL Server 2019, you can have up to 8 secondary replicas. It means an availability group can take a total of 9 replicas, including the primary. So I will add my secondary, which is node 2 here, and my secondary is added. Now, failover types, we have two types of availability mode in SQL Server, right? We have the asynchronous and the synchronous commit mode. Now, with the asynchronous, this is usually very good where your data centers are geographically separated, because definitely there's going to be a network latency and you have also data latency. But since I have everything in the same domain and they are in the same spot, I will go with synchronous commit mode. With this mode, you have two modes of failover. You have automatic failover as well as manual failover. And do I want any of these to be readable if they become the secondary? Yes, for now. And I will create a different video to show you how to uh, enable or configure read-only routing in always on availability group. Now the endpoint here is going to be the mirroring endpoint with the default port number of 5022, right? That is the endpoint for always on availability group. The backup preference, the good thing here is SQL Server gives a couple of preference where you want to take your backup. The first one says prefer secondary, which means that backups will be running on a preferred secondary, right? It says automated backups for this availability group should occur on a secondary replica. If there is no replica, the secondary replica, then the backup will perform on the primary. And then this here says it should only occur on the secondary. So I'm not too okay with this, because most of the time a database is in the secondary, especially if it's in asynchronous commit mode, might not have all up-to-date data, right, to perform the backups. So I will go with primary, and I want my backups to always be running in primary. But if you wanted to load balance your workload in always on availability group, because the secondary replica basically will be as a standalone, and if it's not readable, it's not going to be doing nothing. So we know that all of the read-write connections most of the time are going to the primary replica. So if you still run your backups on the primary replica, that's going to be a little bit like overloading the primary replica with a lot of work, while the secondary is just standing there doing nothing, and it's only waiting for failover. Now, every other thing being equal, if a failover never occurs, it means your secondary would just be there doing nothing, and you'll be paying that license for nothing. So sometimes you want to make sure that you load balance your workload and make the secondary to be at least doing just the backups while your primary is performing every other transactions or incoming transactions. Okay, here basically is the backup priority. You can set it from 1 to 100. So I'm just leaving it default 50-50. So, but if one value is higher than the other, then that one will be a priority when backups needs to be taken. So click on next here. Okay, one thing I didn't show here is the listener. I don't want to create the listener right now because you can create it, but I want to finish with the availability group, then walk you guys through how to create a listener. Read-only routing is a topic for another day. Now, how do you want your data to synchronize in always on availability group? Now, it has 4 possibility modes you can use to synchronize your databases. The first one is automatic seeding, and this one basically has some conditions that has to be met before you can use it. It says it create a database for every selected secondary replica. Automatic seeding requires that data and log file path are the same on every SQL Server instance participating in the availability group. So this is pretty clear. If your data path on the primary is A, on all the secondaries, it should be A, and likewise for all the other drives. Um, and one thing you should know about automatic seeding, if you have a very large database like hundreds of gigabyte or maybe 1 terabyte, it will be very difficult, and it's not advisable to use this just because of the size. And then you also have a full backup where SQL Server will perform a backup for you and restore on the secondary replica, but you will need to provide the backup path, right? You specify the file share path in Windows format. So we're not going to use this one. Then you have the join only. Join only here basically says that you have already taken a full backup and a transaction log backup. It assumes that you've done that already and you've restored on the secondary with no recovery, and that is initialized already. So you can just join the availability group to already existing full and transaction log backup, or you can choose to skip this. So since my system, my setup is respects these automatic seeding conditions, I'm just going to go with this one. And knowing that my Adventure of 2019 is not a huge database, that should work fine for me. So click on next here and you see it performs the validation. Everything is great, and finish. If everything is good, it's just going to run really quick and it will create the availability group for me, and everything should work just fine. Right now, it's trying to configure the endpoint, and there we go. Successful. The availability group is created, and you can see how fast it works. So now let's verify something. Right here, we have our availability group called demo, right? If you expand this, you have every replica that is part of this availability group. And if you expand the replica, you should have node 1 that is the primary and node 2 is the secondary. Availability databases is the Adventure of 2019, and it is just one. Now we haven't yet created a listener. Okay, something to pay attention to here is that we created this availability group and we said the availability mode should be synchronous commit mode, which means by default, this database should show synchronized on both the primary and the secondary. So by just looking at the state of the databases, you can actually tell what availability mode that is. When it's in asynchronous commit mode, the databases will be showing synchronizing, which means there is a possibility of data loss. So let me just refresh this and let's check our database. You see synchronized. Same here. Let me refresh this. You will see it is synchronized. Now, if we change the availability mode, this will show synchronizing. Another thing to pay attention to is always go to your dashboard, availability group dashboard, and make sure that everything is good and healthy. So you can right click here and say show dashboard. It's going to open your availability group dashboard, and you can see everything is healthy on my availability group so far. And it says failover mode here is manual, right? So we can change this to automatic. And to do that, you just have to go to availability group and go to the properties and look at the failover mode here. You can switch this from manual to automatic and click on OK. And you can now refresh this here. This should change from, okay, I didn't even have to refresh it, auto refreshes. And there's an interval for the auto refresh that you can always reset it. And you see it says everything is synchronized with no data loss. So let's go to our secondary and verify the availability group. This is my secondary node. Expand this. And this is my availability group here. Now you see you still have the secondary replica here, and it shows you that it's the secondary. If you expand this, our availability database is there. We don't have no listener yet. So let's go ahead and create a listener on the primary where our availability group is running. To do that, you have to expand this and go to the listener folder, right click here and add listener. To add a listener name, it says what is a listener DNS, right? Domain server name, we're gonna call this one AGLS for availability group listener. And I want this to be running on port 1433, the default port. Now you need to change the IP address from DHCP to static, from dynamic to static. And definitely we have our address range, and this listener should fall within that address range. So click on add. This is the provided IP address here, 92.168.115, and always make sure you don't provide a value that has been used before. If not, it's not going to work, or there might be conflict in the DNS, right? Okay, and click on OK, and our listener should be created right away, and we can test a connection with our listener, right? Once you create a listener here, it also creates an object in the domain controller or in the DNS. So now the diagram I showed you earlier was illustrating how the listener works. So let me bring a new sheet here. So basically, assuming this is our availability databases, we have two availability replicas, and then over this replica, we have the failover cluster. This is our cluster, and now we have our database here, and our database is AdventureWorks 2019. So let's assume there is a user here that is trying to make a connection to our database, and the username is Eric, our famous user. His name is Eric. If this user tries to make a connection to the database, there is an object that we created here that is called the listener. What it does basically, it listens to the connection. It communicates with every node or every replica that is in the availability group, and by default it knows which one is a primary at every given point in time. So let's assume this is our node 1, which is an actual primary, and here is node 2, which is secondary. So node 1 is primary and node 2 is secondary, while this is primary. This is primary. Okay, good. Now we have our database here, AdventureWorks 2019, which is fully synchronized with the secondary here. And in the secondary node, the database is in read-only mode, right? You cannot perform no write operation there. So assuming Eric wanted to make a connection to read data from AdventureWorks 2019, what happens is Eric does not know which server is the primary at this point. But since we have our listener here, the name of our listener is AGLS. Since we have our listener here, and our listener basically knows who is the primary at what given point in time, the listener will route this connection to the primary, because node 1 is the actual primary, and all the read operation will be performed right here. Now, if we had put in place a read-only routing, then what will happen is, if there is a read connection that comes from Eric, as long as he specifies the application intent equals to read only. So as long as this is specified in the connection string, Eric shouldn't have a problem connecting. So if Eric is trying to do a read-only connection to this server, then what's going to happen is that the listener will pick up the connection, and it will notice that there in the connection string there is an application intent to read data only, and it will now forward that read connection to the secondary. That is how it works. That is an internal mechanism of always on availability group with the availability group listener. Now, if something was to happen to the primary node and it goes down, then it will automatically fail over to the secondary. And once it fails over here and data is synchronized, by default, this secondary becomes the new primary. It becomes a new primary. And so any other incoming connection that is a write operation will come and the listener will now point it to the new primary, right? And that is how always on availability group works. So that said, if we go back to our availability group, we can see that we just created our listener and everything looks good. So if we try to perform a connection here, say connection, and then you can provide just the listener name, AGLS. You should be able to connect, and you always connect you to the primary. How do you know that? If you expand here, the availability group, you see that it's connecting to the primary at every given point in time. You can also specify the port number in the connection string of the listener if you have many listeners. So you can say 1433, that was the port number connect, it will still connect, and where it connects always to the primary replica at every given point in time. So this is our always on availability group. Now, a failover, how does a failover occur? There is a manual failover and there is an automatic failover that can be triggered by maybe the help of one database in the availability group or any other thing. And if you wanted to failover, then just go to your, let me connect with my primary actually and show you the failover. Node 1 is a primary. Node 2 is the secondary. So right now, this is the primary, node 1. Let's verify. It's the primary. So to fail over, let's also see what is going to happen here. Just right click here, and this is a manual failover. Click on failover and go through the wizard and perform everything. And you can see from the wizard, it says, I don't have no data loss. Now, this can say this here, that there is what is called in always on availability group, the send queue and the redo queue. Sometimes data is not fully synchronized in as much as your in as much as your dashboard is showing you that is fully synchronized. So you can always go in the availability group here, and you can always add some columns, right? You can always add the last commit time or the last send. You have the log send queue here, and you can look at any last send queue and the last commit queue to compare them, or any last return queue to compare. Is the send queue and the redo queue, are they empty or are they good or are they equal? You can check that by looking at the last the LSN, the last send queue log sequence number. You can also check the redo queue sequence number, and you'll be able to determine, because there is always a lot of lagging either at the primary level because of a lot of transactions in the queue to be sent, or there can be a lot of redo a queue that is backward because of maybe network issues between the primary and the secondary. So again, to fail over, let's go back to our wizard, click on next and connect to the secondary. Click on next and perform a failover. Why it's failing over, I need you to pay attention here, because this is going to change from primary to secondary. Bingo, the failover is done, and you can see now our secondary is now the new primary, and our primary becomes the new secondary. So this brings us to the end of this video. I hope you loved it. I hope you enjoyed it. Please subscribe to our channel, click on the notification bell, and follow us on YouTube. And in the next videos, I will show you how to create read-only routing when it's necessary and how to do that. Now, in the upcoming videos, I'll also show you how to or configure a contain availability group, which is a new feature in SQL Server 2022. Okay, and we will do more hands-on practice. So this is the end of the video. Thank you very much. This was Mambel Technology Group. Stay tuned and keep following us. Thank you. Bye-bye.